Let's start with the very basics, because that's actually not such an easy one. What is OT? What is an industrial control system? Now, the term OT, operational technology, also referred to as IACS, or Industrial Automation Control System, or ICS, Industrial Control System, for me refers to the technology that is used to control and monitor industrial processes. And the difference between the typical IT there for me is that this type of technology manipulates physical processes. It can be opening a valve, closing a valve, running or stopping a conveyor belt, starting a turbine, instructing a robot system in a production process. So all these typical OT systems are designed to manipulate something physical. I think that's an important difference between the IT and the OT worlds. Um, because they have physical impact, they need to be designed to include safety in their design. They need to be robust, they need to be reliable, and they're typically operational 24/7, 365 days a year. Um, when it comes down to securing OT, the Industrial Society of Automation uses the term cybersecurity for OT. I don't very much like this term because the cybersecurity is also used by IT people, so I prefer to use the term cyber physical security that actually properly represents that physical component of what we're going to be talking about. Um, Now, why would it be different from IT? Because after all, they're mostly running Windows and Linux servers, and why is it so different? That I think is an important question. And I think the first answer there is that timing is a critical factor. In the IT world, we basically work 9 to 5, which I know is not completely true in today's world. We're also trying to be available 24/7, but for me, the difference is that in the IT world, you can announce a maintenance window. You can say next Thursday at 6 p.m. we'll reboot this server. You can properly announce that and you can just execute that. That is something that in the operational technology world, in the industrial world, often isn't a possibility. You know, patching, rebooting, stopping an OT system actually has a direct and immediate impact on the revenue of that company. When you stop a system, you stop that factory, you stop producing, and there's a bottom line that's immediately impacted. Now, a secondary difference is about priorities. We all know and love and use, well, or hate sometimes, the CIA triad: confidentiality, integrity, availability. It's very simple. This is what we do. This is what we do in IT. We protect these three in that sequence. Now, in the industrial world, it's somewhat different in a sense that I think priority number one is safety. Again, we're talking about systems that can manipulate something physically, so that can also physically harm a person. So safety will always be our primary concern, and as industrial security people, safety is a difficult one because we know it's our primary concern. We know we have to worry about that, but we also often see that safety is not part of our department or is a different group of people doing it. But still, safety needs to be our number one consideration. And then typically confidentiality, which is first in our IT worlds, is actually the last one. That's the last one of our concerns. We care about safety, and then depending on the type of organization we will be concerned about availability first or integrity first. Now, availability will be, a typical manufacturing organization that just produces a baseline product will care about producing that product. How many products can we manufacture by the end of the day? Now, if you're a medical facility or something like that, you will care first about integrity and then about the production, about the availability. I think a third difference we have to consider is the life cycle of an industrial system. In IT, we replace our systems, what, 3, maybe 5 years. Every 5 years, we have new technology, new systems, new servers, new data centers, new laptops. In the OT world, that's just not at all the case. I mean, instead of looking at years, we're often looking at decades. We design something to run for 10, 20, 30, maybe 50 years. And I think one of the last but important differences are about, adopting new technology. And again, that directly relates to that life cycle management. If you're designing a system that's going to run for more than 10 or 20 years, you're just not looking at the latest version of something, at the newest gadgets that come out. You can't, like in the IT world, in a time span of 10 years, I think we completely changed. We moved a lot of things to the cloud. We have all these new technology. We have AI coming in. We have, I mean, we constantly are able to, get a demo of something, start a proof of concept, implement something, it's running, let's bring it to production. In the OT world, there's a very, very long process before we can actually adopt something new. Now, there's also things I think that the OT world can learn from the IT community, and I think we often don't stress that enough. We often focus on the differences between OT and IT, but there are similarities. Adopting of IT technology, we've come a long way from totally air-gapped systems with serial Modbus connections. We've been adopting IT technology for years. We use Windows computing, we use Linux servers, we finally use TCP/IP networks, and as a result of that, we have firewalls, we have demilitarized zones, we have proxies, we have endpoint protection, we have updates, we have all these things that are now being part of our daily life that for us is new, but the IT world's been doing it for years. So, I mean, don't distrust your IT department, but get their advice on things that they know. The same thing with data. I mean, our physical process are becoming very, very data driven. We're integrating with supply chain partners, with deliveries, with we're optimizing production based on the data. We're providing, I mean, real-time multi-site protection data to sales. We get data from third parties. In some cases, we're even like integrating climate, weather models, wind energy, all these things into our industrial control system. Now, the IT world has this vast expertise in data management, data privacy, and big data, and we should talk to them. We should leverage their expertise and help them optimize our data-driven processes. And the last one's about the cloud. Now, you walk into any manufacturing plant and you talk about the clouds, the first thing that they'll say is, "We don't do cloud. We're not even connected to the internet." Um, and more and more, you notice that that statement is still being made. We still claim that we are air gapped, but in reality, we're not. We have IoT, the Internet of Things, these devices we're using. We have industrial IoT that is cloud managed. We use 4G, 5G networks. We use all different technologies to integrate different sites, and then we start talking about Industry 4.0 and smart factories, and all these are heavily depending on fast-paced, rapid-changing technologies, which are often cloud managed. So there too, I would take the advice, talk to the IT guys. They won't be doing exactly the same thing for you, but they can tell you about the mistakes that they made along the road.